So today we'll start the thermodynamics. Okay. So क्या भी कह लो revision or uh, concept, revision or learning, whatever you say. But today we are going to start the thermodynamics. Okay. It is 14th April. Okay. So time बहुत जल्दी जा रहा. So let's complete it very fast. Okay. So generally in the thermodynamics is derived from the Greek word. Okay, Latin word, in which thermo means heat and dynamics means motion. That motion is due to the action of the force on the moving body. If there is a sudden action on the force on the moving body, then there will be motion, right? Suppose a block of mass is at rest. You need to apply some force. Okay, you need to do some work. Okay, to displace. Okay, so it can be also known as work. All right. So if you do some work on the fluid, it will be in the motion. From rest, it will change state of motion, right? Okay, so thermodynamics, the main aim of the thermodynamics is to convert the non-organized form of energy into organized form of energy. So generally we are focusing on non-organized form of energy, that is heat. How to convert heat into work, that is the main aim of the thermodynamics. And if we talk about the definition of thermodynamics is a branch of science which deals with heat and work interaction and their effects on the properties of the system. Okay, this is based on the basic laws, and those laws cannot be proved, like law of gravity, law of conservation of mass, law of conservation of energy. It tells us what is not possible. Importantly, it tells us about what is not possible. Like if we talk about the second law of thermodynamics, it tells us that 100% of efficiency is not achievable. Okay, so it tells you that, okay, how to study the thermodynamics. There are two approaches to study the thermodynamics. One is microscopic approach, also known as statistical approach, and macroscopic approach, which is classical approach. Okay, and when we talk about the microscopic approach, microscopic in the sense we are focusing on each and every small molecule. Okay, each and every molecule in the matter. Okay, if you focus each and every molecule, then it will be very complex to look at the behavior of the molecule. Okay, and likewise we are studying about the individual behavior of the molecule. Okay, it is also known as statistical thermodynamics. Okay, like low pressure, low density and low pressure gases. Wait, and if we sum up their behavior, then we will know the behavior by the statistical means. It is useful for low density and low pressure gases. Microscopic approach is useful for low density and low pressure gases. This we will learn in the next microscopic viewpoint. In the microscopic viewpoint, we are selecting a small certain quantity of matter with, which is not undergoing the molecular effect. Okay, so an average behavior is considered here, and we are going to establish the relation between measurable and measurable properties. Like measurable properties, they are pressure, volume, temperature. Non-measurable properties, enthalpy, entropy, and internal energy, etc. Okay. So generally in the thermodynamics we are studying about the macroscopic viewpoint. Why not microscopic viewpoint? Because to study microscopic viewpoint, it is very tedious process. Okay, each molecule has 6 degrees of freedom, 3 rotation and 3 translations. Okay, there will be 6 equations. To solve those 6 equations, it is very difficult. And that too, if we want to study some volume and some quantity of matter, so we are summing up the each and every individual behavior. Okay, so for that it is very difficult, and it is microscopic viewpoint is only useful for low pressure and low density and low pressure gases. But macroscopic viewpoint, we are selecting one volume. Okay, so here comes the concept of continuum. How to apply the macroscopic viewpoint, how to apply. Okay, so generally we are selecting small volume quantity of matter. So if we consider that quantity of matter, generally due to the molecular effect, if we look at the small quantity of matter, there will be inside that small volume there will be large number of molecules, right? If we are consider small volume, there will be large number of molecules. Okay, and also those molecules, due to the molecular effect of those molecules, the molecules will try to go out from the selected As you selected some small quantity, small region in space, a small, so those molecules will try to move from that volume. So we need to select one small volume. We need to select one small minimum volume in which we have to consider the averaging matter is treated as continuous. So if you consider this small volume, so generally due to there is a variation in density due to the molecular uh, due to the molecular effect, there will be variation in density. So if we increasing the volume, then the variation in density will be very small, very less, going on decrease. So at one point, matter is treated as continuous. All right. To check the concept of a continuum is valid or not, we must look at the concept of Knudsen number. Okay, Knudsen number mean true path by characteristic dimensions. Mean true path is nothing but the average distance traveled with the molecule between two successive collisions. Okay. So after this season, so generally these are not useful, but in the interviews you will ask these questions. Okay. So if you want to study deeply, then you have to look for the various resources, but don't worry about these little things. Okay, about the concept of continuum, why we are going to use the concept of continuum, why thermodynamics, why second law, first law, third law, why zeroth law. These are the things. Okay. Why, how the first law came into picture. Okay, these are the things which are not useful for the from the exam point of view. In the exam point of view, will test you by you know by the basic concepts. Okay, these are the basics से भी basics को समझने के लिए basics, but how the things come into picture, these are the things to study these things. Okay, in the interviews you can follow, you can use different tutors after getting the rank. First of all, get the rank. Okay, so that is the thing. Okay, next we are going to look at the thermodynamic system. If you want to talk about the thermodynamic system is generally a quantity or region or space. Quantity or region of or space in which our focus, in which जहाँ पे हम लोग focus करते हैं. Okay, so in our attention is focused. Okay, so suppose for example, if there is a cylinder, in the cylinder there is a water. So water, I assume the water is as system. Okay, because our focus is on water. So external to the system is surroundings. Whatever the system के आगे जो भी है, that is the surroundings. Okay, and the system is separated by the boundary. Okay, system is separated by, I drawn the diagram. Okay, so generally our focus is on certain quantity. System may can I can assume that this room has a system. I can assume this room has a system. Okay, so whatever the air in this room, so I can assume that it is as a system. Okay, so the walls of this room is a boundary. So boundary can be of two types. The boundary can be real boundary. The boundary can be imaginary boundary. Okay, so whatever the walls are there, these are the real boundaries. Okay, boundary can be imaginary. Okay, so in the real boundary can be fixed or boundary can be moving. Okay, as these walls are fixed, it is in the piston cylinder assembly. If we consider the cylinder as our boundary, then cylinder is fixed. Okay, if I consider piston as our boundary, then the piston will be moving. Okay, and if we talk about the imaginary boundary, if we talk about the real boundary will not allow to mass transfer to takes place. Okay, but imaginary boundary will allow mass transfer to takes place. Okay, so in order to for work to be done, for work, if you want to say that work is said to be done, then the boundary must be moving. One boundary must move. All right. Also, if you want to talk about the Wait. So generally, when we are talking about the types of thermodynamic systems, there will be three types of thermodynamic systems, right? First one is closed system, and open system, and isolated system. If you talk about the closed system, sir, closed system, our focus main there is no mass interaction. Okay, there is no mass interaction. Mass will be constant. Okay, and uh, and our focus is on basically our focus will be on that particular mass which is constant. Okay, our focus is on some quantity of mass, so we'll call it as a control mass system. Okay, and energy interaction will take place, work interaction may or may not takes place. Okay, so if someone gives you the system and tells you that whether it is a closed system or not. Okay, suppose for example, if he has given a rigid box or rigid container in which the gas of some mass m is filled. So if he ask you that it is a control mass or not, control mass system or closed system or not, you just look at the mass. If the mass is constant, then you can say that mass it is a control mass system. It is mass is not constant, then you can say that it is not the control mass system. Also, the work interaction may or may not take place. Suppose if you consider a rigid container, their work interaction will not take place because it is volume is constant and also mass is constant. All right, so work done will be zero. If you consider piston cylinder arrangement in which the mass is constant, then there will be work done because the work is said to be done when the energy causes the boundary. Okay, the piston is moving, right? It does work on the mass. That is the thing. So if we talk about the open system, then in the open system our focus is on the particular volume. Our focus is will be on a particular volume. Okay, so if then we can call it as a control volume systems. Okay, energy interaction and work interaction will take place in the open systems. Example, turbines, compressor, etc. are the examples of open systems. Our focus is on generally fixed region in space. All right, after discussing open system, let's discuss isolated system. Isolated system is a system in which no energy and no mass transfer takes place. Okay, it is a perfectly insulated container and rigid container. Perfectly insulated rigid container also the universe is taken as the isolated system in which though there is no energy and work interaction. No mass can enter, no mass can leave. Okay, no heat interaction, no work interaction, no mass can enter the isolated system. Alright, so next discuss about the thermodynamic property. What is thermodynamic property? Thermodynamic property is actually a thermodynamic property is you know ki, uh, it is generally characteristics. Properties are the characteristics of the system. Okay, by which the system can be identified. There are two types of properties. There are intrinsic properties and extrinsic properties. Intrinsic properties independent of mass. Extrinsic property dependent upon mass. Intrinsic properties which are not dependent upon mass are density, temperature. Temperature, for example, if you take one room, temperature say 33 degrees centigrade. If you divide that room into two halves, can you say that temperature will be in one part will be 12 point something? No, temperature will be 33 itself. Okay, so temperature cannot be divided. So that is independent of mass. Temperature of air, 1 kg of air is say 50 degrees centigrade. Temperature of half kg, if you divide half, temperature of half kg can't be 25, it will be 50 itself. Okay, that is the thing. So density in the same density is mass by volume, right? So we cannot say density is inversely proportional 1 by volume. As the volume is increasing, density is decreasing. Volume will increase if we increase the mass. Okay, so volume is increasing, density is decreasing, we can't say, because mass by density equal mass by volume, these two terms mass by volume, these are dependent parameters, they both depend upon each other. We can provide the proportionality symbol when these are independent parameters. Okay, numerator and denominator must be independent with each other, then we can say that density is inversely proportional 1 by volume, but here we can't say. Okay, Also, when we talk about the extrinsic properties, these are dependent upon mass. All the energies, internal energy, entropy, enthalpy, these all are properties which are dependent upon mass. Okay, mass itself, volume itself. Okay, magnetic forces, electrical forces. These all are dependent upon mass. Okay, so these are the extrinsic properties, and one of the way to determine these properties is divide those properties. Okay, suppose for example, if you divide viscosity, sorry, pressure. If you take pressure, if your pressure is suppose say 50 kPa or MPa, so if you divide into two halves, pressure can be divided, right? If you atmospheric pressure is acted upon you, so if I break you into two pieces, the atmospheric pressure can't be half, it will be one atom only. So that's why pressure is independent of mass, that is intrinsic property. Okay, and if you talk about the intrinsic and these, if you talk about these properties, the ratio of two intrinsic property to extrinsic property is always an intrinsic property. Ratio of two extrinsic properties is an intrinsic property. If we divide intrinsic property with the mass, that is specific and extrinsic properties also and intrinsic properties. If you want to convert extrinsic property into intrinsic property, there will be two conditions. First of all, it must be a specific extrinsic property, it must be divided with mass, or two extrinsic properties can be converted into intrinsic property by dividing with them. Okay, so this is the thing. And next, properties are independent of past history. Properties are independent of past history. uh, we cannot say how the temperature is achieved. Okay, it does not depend upon the if the temperature is 50, you can't ask that how the temperature came to 50. Okay, the volume is, so how you increase the volume, you cannot say. Okay, you can't say because it is not an unnecessary thing, not an important thing. Okay, the bodies are the point functions or state functions, but not path functions. If you talk about point function, path function, point functions are the functions which are independent of path. Suppose temperature, you can plot the temperature at anywhere in the graph. Okay, if you want to plot the work you must work is path dependent process. Okay, these are point functions. Properties are the point functions, not path functions. And these are exact differentials. So one मैं जब भी ये प्रॉब्लम कर रहा था, तो मैं एक चीज़ से गुजर रहा था कि हाउ टू सॉल्व दिस प्रॉब्लम. सो हाउ टू सॉल्व द एग्जैक्ट डिफरेंशियल. ओके, जनरली एग्जैक्ट डिफरेंशियल कैन बी रिटन एज z इक्वल टू एम डी एक्स प्लस एन डी वाई. ये आसान तरीका याद रख लेने के लिए मैं ये करा कि m टेंस टू x, m यानी x, n यानी y. ओके, whenever you are write them in the brackets, then write x. If you write x, then x is related with m, so dou m by dou y आता है यहाँ पे, dou x नहीं आता, ऑलरेडी x आ गया, y आता. ठीक है, ऐसा इक्वल टू y लिख लो, y is related with n, dou n by dou x into y. okay, this is the thing. So कांस्टेंट्स में लाके डिफरेंशिएट करे बोले तो डिफरेंशिएशन ऑफ कांस्टेंट इज जीरो, और यू कैन डिफरेंशिएट विद रिस्पेक्ट टू एनी terms. Okay, so if you differentiate dou m by dou x, dou m by dou y into x equal to dou n by dou x into y, ये दो इक्वल रहना, अगर से दो इक्वल रहे तो exact differential. Properties are the exact differentials. Okay, now let's talk about the state of the system. Okay, so after discussing the intrinsic and extrinsic properties, let's talk about the state of the system. Okay, state is generally the condition of the system. Okay, the condition of the system is generally found by the properties of the system. Okay, so next we'll talk about the Gibbs phase rule. What is Gibbs phase rule? Gibbs phase rule is nothing but, suppose for example, if there are total properties of the system are m, total independent properties are n, so total dependent properties will be 1, m minus 1. So if minimum number of independent properties are fixed, then the total m minus 1 properties will be automatically fixed. So to determine the m minus 1 number of, to determine the minimum number of independent properties, we are going to use the Gibbs variable. Okay, p plus f equal to c plus 2. This is for water. Okay, where p is equal to, p is number of phases, f is degree of freedom, c is number of components, and 2. So components for H2O, there is only one component, that is H2O. Okay, people assume that two molecules, one hydrogen and two hydrogens and one oxygen, three components. No, it is only one component. Okay, p plus f, if we substitute p plus f equal to c plus 2 for H2O water, then you will get phases are 1 plus F equal to components are 1 plus 2. 3 minus 1, that is degree of freedom is 2. Okay, the pressure or temperature gives will not say what are those properties, minimum number of independent properties. This will not tell that what are those independent properties. Okay, and again when we talk about steam plus water, steam is one phase and water is one phase, two phases. Now 2 plus F equal to 3. Okay, F will be equal to 1. Degree of freedom is 1. Either P or T. There are 3 phases. Then F equal to 0. All properties are none. Next, process and path. What is process? Change of the states is known as process. Change of the states is known as process, and the path is nothing but series of equilibrium states which series of equilibrium states which a system passes during the process is known as path of process. Okay, series of equilibrium states in which the system passes through the process is known as path. Now if you talk about the process, there are mainly two important processes are there: reversible process and irreversible process. Reversible process in the sense that same path the system will travel in the same path. Suppose for example, if 1 to 2 is a path, I drawn a figure. Okay, 1 to 2 is a path. So it will for if you want to come from 2 to 1, it will take the same path. Suppose for example, if the lift is there, lift is going up, it is taking the same path down. Okay, that is the reversible process. If you talk about the irreversible process in the sense it will be difficult path. Okay, first different path. First 1 to 2 is one path, and if you want to come from 2 to 1, then it will take the different path. Okay, the irreversibility is due to friction. Okay, irreversibility is due to friction. So why we are using this, why we are learning about this reversible and irreversible processes, we'll learn afterwards. Okay, next is quasi-static process. Okay, after discussing process and path, let's talk about the quasi-static process. So in the quasi-static process, quasi-static means almost static. Okay, it is almost static process. Static means almost slow process. It is very slow process. Okay, so generally why we are knowing about this process. Okay, इसके बारे में क्या पढ़ रहे generally. तो क्या होता है generally if we talk about the piston cylinder assembly or there is a certain gas. Okay, so अगर से हम अपन weights रखें इसमें कि छोटे small fractions of weights. Okay, so if you want to plot the graph between the pressure and temperature. Okay, if I increase दो properties के बीच में अगर से मैं ग्राफ डालना है तो सपोज मैं ले तो इनिशियल प्रेशर और इनिशियल टेम्परेचर क्या था. then I am going to add the weight ऐड करते जाता हूँ मैं. तो क्या होता है, प्रेशर भी चेंज होता है, टेम्परेचर भी चेंज होता है, राइट. सो उसके रीडिंग्स में डालते रहता हूँ, छोटा वेट ऐड करता हूँ, छोटा वेट. ओके, देन आई एम गोइंग टू प्लॉट द ग्राफ. ओके, सो अगर से मैं वेट्स निकाला बोले तो इट विल बी, अगर से फ्रिक्शन नहीं रहा तो इट विल फॉलो द सेम पाथ. ओके, सो क्वासी-स्टैटिक प्रोसेस इज ए वेरी स्लो प्रोसेस. अगर से स्पॉन्टेनियस प्रोसेस के लिए मैं अगर से मेरे को पाथ ड्रॉ करना है तो आई कांट ड्रॉ द पाथ बाय फॉर द स्पॉन्टेनियस प्रोसेस. So quasi-static process is a very slow process. Quasi-static process plus reversible frictionless is equal to reversible. Frictionless quasi-static process है reversible process. Right. So ये हो गया quasi-static process. Thermodynamic cycle में आने end point and starting point and end point, initial and final states. The initial and final states are same. Then we can say it as a thermodynamic cycle. Thermodynamic equilibrium. In order to say that bodies in thermodynamic equilibrium, that equilibrium must be achieved. Mechanical equilibrium, thermal equilibrium, chemical equilibrium. Mechanical equilibrium, then there must not be any unbalanced force which tends to move for the motion of the body. All the properties must be same. All right. So that is in mechanical equilibrium. Thermal equilibrium, the all temperature must be same. Chemical equilibrium, there must be no mass transfer and chemical transfer must take place. Endothermic, exothermic chemical reactions नहीं होना. All right. So if the three equilibriums are okay, then I can say then body is thermal equilibrium. Okay. Next, the concept of ideal gas. Ideal gas, if a gas behaves the ideal gas behaves the ideal gas equation, then we can say that it is an ideal gas. P equal to mRT. So generally there is a Boyle's law. ये कहाँ से आया? Boyle's law रहता. P is inversely proportional only by volume. If the temperature is constant and pressure is directly proportional to the temperature. Temperature is directly proportional to volume. Temperature constant. Pressure is directly proportional to temperature at volume constant. Okay. Charles law के है वो. So when you sum of all these things, P equal to mRT देता. P must be in kelvins. P must be in kPa. And R क्या है? Gas constant है. Gas constant किलोजूल पर kg Kelvin. M mass in kg. Okay, these are the things. So PV equal to nR bar T. ये भी एक इक्वेशन है. Where n is the number of moles, R is universal gas constant at 0.14 किलोजूल पर kg Kelvin. इसकी वैल्यू रहती. फिर टेम्परेचर जो ये चीज़ें हैं. ओके. सो n वो कहाँ से आया? n आंटी कहाँ से आया बोले तो n इक्वल टू ये स्मॉल m by कैपिटल M. We know this. Okay. And n into capital M equal to small m. If we substitute, then n capital M, small n capital M R T. Mr is constant. Okay, Mr is constant. Is from Avogadro's hypothesis. Mr equal to R bar. Okay, Mr कौन से भी गैस के लिए Mr constant रहता from the Avogadro's hypothesis. Okay, so Mr को R bar से replace करो, then you will get PV equal to n R bar T. Okay, this is the thing. So generally in the kinetic theory, ideal gas किसको बोल सकते हैं अपन? And generally all the gases are ideal gas? No, each and every gas is not an ideal gas. In ideal gas, intermolecular forces are zero. Also a gas is said to be an ideal gas then when a gas is at low pressure. Pressure is nearly less than 10 kPa and at high temperature is greater than 2 times critical temperature. Okay. Then the gas behaves like an ideal gas. Next, according to kinetic theory of gases, there is no gases will not occupy the volume. Thus is the first point, and the second point is there is no interactive forces between the molecules. Okay, so these two are considered by Clausius and van der Waals. So Clausius considered there is a free space for the movement of the molecule. Okay, PV minus B equal to mRT. Clausius considered van der Waals क्या करा? There is an intermolecular forces. V minus B का इगू करा, minus B का इगू करा बोले तो generally we consider the volume, total volume. So minus B, ये B क्या है? Correction factor है. Next P plus A by V square, P plus A by V square into V minus B equal to mRT. ये दिया van der Waals equation. van der Waals consider A by V square क्या है? Correction factor है. Okay, this is about the ideal basics of ideal gas. Okay, so next when we talk about the mixture of ideal gases, then finding R for gases, that is gas constant for gas. For air, if you want to find, then from Avogadro's hypothesis we know that mR equal to R bar, right? Yeah, R will be equal to R bar by M. R bar is a constant, universal gas constant, and whose value is 8.314, and also molecular weight we know for the each and every gas. So just divide it, we will get one value in R. Okay. And next thing is that ideal gas, there are two types, perfect gas and semi-perfect gas. In the perfect gas, Cp and Cv are constant. The semi-perfect gas, Cp and Cv are not constant with respect to temperature. Okay, if you want to find the Cp and Cv value, Cp minus Cv equal to R. Okay. And also adiabatic index, we are going to introduce adiabatic index. Adiabatic index is the ratio of Cp by Cv, which is denoted by gamma. So I think we discussed it till Cp, Cv, finding Cp and Cv. So now let's discuss about the mixture of ideal gases. In the mixture of ideal gases, there is one law, Dalton's law of actual pressure. The sum of the all pressures will be equal to only one pressure. Okay, and summation of n will be equal to n1 plus n2 plus so on. Okay, from here we will get PV equal to summation of n RT. Alright, so there is a mole fraction. First of all, the concept of mole fraction is that ratio of number of moles of the gas to total number of moles of the gas. Okay, so mole fraction of ith gas equal to number of moles of the gas divided by summation of the number of moles of the gas. Okay, and will partial to find the partial pressure, to find the pressure of the ith gas. There is one formula, pi equal to xi times p. So from where does this came from? We know that pi partial pressure of partial pi v equal to ni rt. Okay, divide with pv by nrt, summation of nrt. So ni by summation of n gives you xi, so p by pi by p. So just r will cancel, t will cancel, you will get pi will be equal to xi times p. Okay, alright. So mass fraction, ratio of mass of the gas to the total mass of the gas is known as, so we know that n equal to n of ith gas will be equal to m by m, summation of m by m equal summation of n will be equal to m equivalent times ni. If we divide with mass, total mass, mi by m is mi equal to ni by summation of n is xi times m equivalent, mi by me. Alright, so this is the one equation relation between the mass of mole fraction of ith gas and mole fraction of ith gas. So again, the R equivalent, m equivalent, cv equivalent, cp mixture, r mixture, m mixture, you can find it by using the simple trick, that is mrt. So if you want to find r equivalent, then r1 m1 plus m2 r2 plus so on up to divided by m1 plus m2. If you want to find m equivalent, then n small n capital M r1t, right? So n1 m1 plus n2 n2 so on by n1 plus n2. If you want to find the cv mixture, then there is one formula, m1 cv1 plus m2 cv2 by m1 plus m2. If you want to cp mixture, then m1 cp1 plus m2 cp2 so on. So these are the formulas, these are the important formulas which I discussed. Okay, these are the formulas are useful in solving the numericals. Okay, next we will discuss about the concept of temperature. Okay, let's go. Come on. Concept of temperature. What is temperature actually? Temperature can be viewed from 2 points. Okay, microscopic viewpoint and microscopic viewpoint. In the microscopic viewpoint, temperature is generally a property. With the change in this property, with the difference in this property, this property changes, then the heat flows. Okay, from the microscopic viewpoint, temperature is generally average kinetic energy of a body. Okay, so zeroth law gives the concept of temperature. Zeroth law tells that when the three bodies are there, two bodies are in equilibrium, body A and body B are in equilibrium. If A and B are connected diathermally and B and C are connected diathermally, then these two bodies are in equilibrium, then the other two bodies will be in equilibrium. Right? Temperature A equal to temperature of B, temperature of B equal to temperature of C, then temperature of A will be equal to temperature of C. So from here you come to know that body 3 will be also in thermal equilibrium with these two bodies. Okay, this gives the concept of temperature. Okay, temperature, measurement of temperature. Thermometry is generally a process of measuring the temperature of the unknown system. Okay, generally we are taking thermometry property like let property of the system will be a x. This property will vary with respect to temperature. So this property is found out, and next system is taken, and we can find the unknown temperature of that system with the help of this thermometry property. Okay, the property which we are using, which is varying with respect to temperature, the property which we are using is known as thermometry property. There are different types of thermometers. Okay, first of all, mercury thermometer, length is the thermometry property. The length is changing with respect to temperature, and we are क्या बोलते हैं इसको, वही लेंथ को लेके हम लोग जो है ना अननोन बॉडी टेम्परेचर को मेजर करते हैं. ओके, by calibrating that length. Next is constant volume gas thermometer. In this, pressure is varying with respect to temperature. Pressure is a thermometric property. Constant pressure gas thermometer, volume is a thermometer, thermistor electrical resistance, and thermocouple EMF, pyrometer, intensity of radiation. These are the properties. Okay, and how to measure the methods to measure the temperatures. First method is two reference point method. Two reference point method. Two reference point method is ice point and steam point are taken. Ice point is 0 degrees centigrade, steam point is 100 degrees centigrade. These 2 points are taken, okay. And T equal to A plus BP, right? T equal to A plus, this is the equation. Substitute this equation, find out A and B and find out the final temperature. By solving, we will get T equal to minus 100 into Pi by Ps minus Pi plus 100 into P by Ps minus Pi. Like this, you can find out the temperature. Single point reference temperature. In the single point reference temperature, the temperature at the critical point temperature is taken. The temperature at triple point is taken 273.16 Kelvin. T equal to AP. If you substitute T at T, P will be equal to temperature of triple point. A is found out. So A if you substitute, then you will get T will be equal to 273 something the P of P triple point into P. So if you know the pressure, you can know the temperature. So this is a single point temperature. This completes our first unit successfully. Okay. So we will solve this problem. We solve the problems of this unit in in revision. Alright. So now we will start with our next unit, that is work and heat. So if we discuss about the special cases for the work transfer. So the case number 1 is gas, the rigid container. Okay. So in this case 1, we are taking a battery and motor is there. Motor shaft is stator is connected inside the rigid container. Okay. Now if we take the if we focus on the if we take a system rigid containers as a system, then in that there is a gas. So PdV will be 0. Why PdV will be 0? Because volume is not changing. Okay, gas is not expanding. Volume is constant. Displacement work, PdV work will be 0. But there is an external work, right? Electrical resistance. Due to electrical resistance, there is a work. Okay, there is a shaft work. All right. So work will be not 0. Work will not be 0. Okay. So we discussed in some of the problems, like there will be fan. If you consider a room as our system, and if you consider the fan and so many things, then the work due to constant volume will be 0, right? Volume is constant, then the work will be 0, but electrical work will be there. Okay. So this is about the case 1. Now if we talk about the case 2, there are 2 partitions. If we consider total partition 1 as our system. Okay. So volume is changing, actually. Volume is changing. Okay. Volume is changing. So if the volume is changes, then displacement work will not be 0. Okay. The pressure will also be there. Okay. The displacement work will not be 0. But if we talk about the work W will be 0, because there is no resistance offered by the surroundings. Right. There is no shaft, there is no electrical work, etc. So since there is no shaft work, electrical work, it means that the surrounding is not offering any resistance to our system. So therefore W will be 0, but PdV will not be 0. So, and the second one is that in the second case, the gas is expanding, right? So if the gas is expanding, then why we can't write W equal to PdV, integral PdV? Because this process is known as highly free expansion process. In the free expansion process, expansion against the evacuated chamber is known as free expansion process. In this expansion process, there is no resistance offered by the surroundings. Okay, this is very highly reversible process. Therefore, we can't write W equal to PdV. Alright, W equal to PdV. Since there is no expansion offered by the surroundings, we are writing W equal to 0, but not PdV will be equal to 0. Okay. So now we are going to talk about the open system. First law for open system. So what is open system, sir? In open system, mass will there will be mass interaction and also energy interaction. In open system, we talked about the fixed mass, right? Here we talk about the mass flow rate. In the open system, we are going to talk about the mass flow rates. Okay. Mass flow rate is known as mass which is flowing per unit time. Okay. Now, in the open system, first of all, there is a conservation of mass. Okay, conservation of mass. According to law of conservation of mass entering must be equal to mass leaving. Okay, mass entering must be equal to mass leaving. Suppose, for example, if If 10 kg of mass is entering and 8 kg of mass is leaving, 8 kg per second mass is leaving, then 2 kg per second mass is accumulated, right? How can I write it? I write this 10 kg minus 8 kg equal to 2 kg, where 10 kg is mass at inlet and 8 kg is mass at outlet and 2 kg is mass accumulated. Okay, so rate of mass accumulated is 2 kg per second. So thus the system is steady or unsteady. System will be unsteady because the properties are changing with respect to time. The mass is changing with respect to time. The mass is accumulating. So whatever the properties are changing with respect to time, and also the properties which depend upon the mass will also be changes. Those properties which depends upon the mass are known as extrinsic properties. Those properties will be changes. They will also changes due to accumulation of mass. Okay, so first of all we will talk about the unsteady open flow for unsteady state. Okay, steady state. In the steady state, mass of inlet will be equal to mass of outlet. Okay, mass inlet must be equal to mass at outlet. Again there is a small derivation, right? So density equal to mass by volume, right? Mass will be equal to density times volume, and volume can be I can write by AL. If I divide with the whole term by T, length per time is velocity. Okay, mass will be equal to rho AC. This is the derived formula, and rho 1 A1 C1 will be equal to rho 2 A2 C2, and also we know density equal to 1 by volume, right? A1 C1 by specific volume V1 will be equal to A2 C2 by specific volume V2. Okay, so in the open system, there generally we are talking about the two works: external work and open flow work. Flow work and external work. External work is the work which is work like turbine work, shaft work, compressor shaft work. Okay, these works are known as external works. Okay, and the flow work is the work which is responsible for the flow of fluids. Okay, suppose for example in the diagram he considered the small fluid element, right? And he considers the piston. That is not actually the piston, but that is another fluid element. Okay, which forces the fluid for enter to enter. Okay, which forces the fluid to enter. Okay, so flow work causes the fluid element to enter or leave the system. Okay, this flow work is due to normal fluid force. Okay, but external work is not due to the normal fluid force. But consider here both the works are crossing the boundaries. Work is said to be done when the energy crosses the boundary, right? So both the works are crossing both the works the energy is crossing the boundaries. But the main difference is that in the open flow work, that is due to normal fluid force. In the external work, the work is other than the normal fluid force. Okay, both are crossing the boundary. So if you talk about the energy balance, the law of conservation of energy and mass, energy entering minus energy exit, energy at the exit equal to energy accumulated, right? If 10 kilojoule of energy is entering, right, from different modes, like kinetic energy, potential energy, heat, work, etc. Different modes. If 10 kilojoule of energy is entering and 8 kilojoule of energy is leaving, then energy accumulated is 2 kilojoules. Okay, so energy is a property, right? Each and every property will change, like temperature, pressure, volume. These all properties will change. So this is a problem for unsteady. So if you talk about the steady, my energy entering must be equal to energy leaving. So this is the thing. Okay, so now let's derive the formula for the first law, steady flow energy equation for the first law for the open system. Okay, so generally when the energy is entering, like energy entering we consider, right? Energy entering by different modes. Okay, generally energy entered by which means by the fluid. Okay, the fluid is entering, the fluid has some energy. Okay, let's analyze the what type of energies will be there. First of all, when the fluid is moving with some velocity, there will be kinetic energy. Okay, fluid has a kinetic energy. Again, if we consider the datum, then the fluid has a potential energy, right? And if we consider the temperature of the fluid, then the fluid also has that kinetic energy. Internal energy. So these are the three energies which the fluid possesses, right? Kinetic energy, potential energy, and internal energy. Now, if you write the conservation of mass and conservation of energy equations, like m1 dot equal to m2 dot equal to m dot, and we are deriving for steady flow energy equation, right? We are deriving for the steady flow. So energy 1 will be equal to energy 2 will be equal to energy. Okay, so energy 1 will be equal to energy entering will be equal to half m dot c. Okay, we are writing m dot. What is meant by m dot and m? M dot is nothing but kg per second. It is the rate of mass flow rate, okay, rate of mass which is flowing per second. If you write u dot, internal energy per second, okay, if you write c dot, we will write kinetic energy per second, okay. So that is the thing, okay. So half m c1 square plus m dot g1 z1, okay, plus u1. Now we are adding q, in this equation. So this is energy entering with the equation of the energy entering. Next, if you write the energy equation for the energy leaving, then half m dot c2 square plus m g2 z2, m dot g2 z2 plus u2. Here we are writing plus w, okay. Why we wrote q in the above equation and why we wrote w in the below equation? Why? Because I am assuming, I am considering that I am supplying some energy q, okay, to the system. I am supplying some energy q to the system and I am getting some work, positive work, okay. I am considering that thing, okay. And again, if you consider w can be again classified into two types, okay. One is flow work and one is external work. External work is work done by the turbine, work which is required for the compressor, etc. And open flow work, is responsible for the flow of fluid, okay, minus p1 v1 minus p2 v2. Again, I am not considering direct p1 v1, I am considering p1 v1 dot, p2 v2 dot. What is v1 dot? Volume per second, okay. P1 v1 dot, p2 v2 dot. All right. So if I write the equation, I will get half m dot c1 square plus m dot g1 z1 plus u1 plus q dot, okay, u1 dot plus q dot will be equal to half m dot c2 square plus m dot g2 z2 plus u2 plus minus p1 v1 dot. P1 v1 dot can be also written as v, and wait, I can write as well specific volume as v dot by m dot, no? Again, specific volume times m dot gives me volume, okay. So I can write v dot m dot p1 v1 dot m dot p1 plus v2 dot p2 m2 dot plus w external work. I am considering that external work is positive, okay. I am considering with the help of this equation I can make the changes, right? If I want to, if the work is done by the system, then I consider the negative symbol, okay, in the problem. So all right. So now I am considering the work which work we are getting the positive work on the system, okay. Again, if you write, enthalpy will be equal to h equal to u plus pv. Specific enthalpy equal to small u plus p into v, specific, right? So I will get m dot into h1 plus m dot into h1 plus half m dot c1 square plus g1 z1, okay. If I take m dot common, then h1 plus half c1 square plus g1 z1, okay, bracket close, plus q, we will get this equation. But now if I consider the one term m dot h1 will be in the form of kilojoule per second, right? M dot is kilojoule, kg per second. If we multiply it, we will get kilojoule per kg. Okay, for one equation we are getting kilojoule per second. We consider the one equation we are getting in kilojoule per second. All right. Kilojoule per second. If we consider the one equation, we are getting kilojoule per second. If I take m dot common, we are getting kilojoule per kg. Okay, so if I look at the second term, half c1 square, units are in joules per second. Okay, joules per kg. I need in kilojoules per kg. So I am doing, I am dividing with 1000. 2 times 1000 will get 2000, right? Again, per kinetic energy, potential energy, we are dividing with 1000, okay. To get the units in kilojoule per kg, internal units are kilojoule per kg, and not is in kilojoule kg per second. If you multiply these two terms, we will get kilojoule per second, kilojoule per second, kilojoule per second. What about q dot? Q dot is in kilojoule per second, okay, and w dot is in kilojoule per second. So this is the equation number 1. If I want the equation number 2, I am doing, I am dividing the whole equation by m dot. If I divide the whole equation by m dot, I will get the same equation, but there are certain changes, like q dot will be converted into small q. Why small q? Why not small q dot? Why not small q dot? Because kilojoule per second by kg per second. Second will cancel kilojoule per kg. I will get in small q. And similarly, work I will get in small w. But things to be noted that it is not small q dot. It is not small w dot. Okay. It is only q and w. It is not. It is not the rate of the energy. It is the direct energy. Okay, which is independent of time. All right. So I got these two equations. So this is the equations are known as steady flow equations for and energy equations for one flow.